this is Geometry Lesson 4.4, using corresponding parts of congruent triangles. The objective for this lesson is that you will be able to use triangle congruence and corresponding parts of triangles to prove that parts of two triangles are congruent. Basically, all the proofs that go with this lesson, everything goes with this lesson, is one step farther than what we've done before. So, let's take a look at this problem first and have a discussion. It says, if you know two triangles are congruent, then you know that every pair of their corresponding parts is also congruent. That's how we started off this chapter. We had to prove that everything was congruent. If we could show that everything was congruent, then we could say, well, in fact, these shapes are congruent. Now what we're saying is, hey, if you can use angle, side, 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 or angle, side to prove congruent triangles, then you've shown that everything about these triangles are congruent. So let's take a look at these three triangles. It says, is triangle ABC congruent to triangle GHI? So ABC is this first triangle and GHI is the third triangle up there. So the first thing that I did is I looked, okay, ABC has a 1 congruent marker on AB and a 2 congruent marker on BC. And GHI has a 3 congruent marker on GI. So none of the sides line up right now. Then I looked at their angles. I see angle B is 80 degrees and angle H is 80 degrees. That is good. Angle B is congruent to angle H. Now that's all the things I saw that these two have in common, and since they both have 80 degrees, I would put a congruent marker on both of those. Now we can't really make any more comparisons between these two triangles, but we do have a third triangle here in the middle. And we can make comparisons between these two triangles and this third one. It says, is ABC congruent to GHI? How do you know? Well, if I'm looking at DEF, I can see that AB and DE have the same congruent marker on them. And BC and EF have the same congruent marker on them. That's pretty good. Now I look, okay, I've got an 80-degree angle for angle B, and I don't know what my angle that E would be. But I do know angles D and F, 62 and 38. And I can use the 180 relationship to find the measure of angle E. And I start to solve from there. 62 plus 38, that's going to give me 100. And I get the measure of angle E is 80 degrees. Oops. Well, that's really helpful because we know that angle B is 80 and angle E is 80. If you look at that now, in triangle ABC, you've got a side, and in triangle DE, you have a side that are congruent. Then they both have this angle of 80 degrees, and then they both have another side. Triangle ABC is in fact congruent to triangle DEF by side angle side. But the goal is to see if ABC is congruent to this GHI triangle. So let's see how GHI compares to ABC. They both have an 80-degree angle, and they both have this 3 marker for a side, and they both have this 38 degrees. So there's another angle. Now if we compare these, they both have a side, and the side is not the one in between the two angles. So when I look at that, I'm going to start at the angle opposite it. So I've got an angle, and a side. I've got an angle, and a side. That means that triangle DEF is in fact congruent to triangle GHI by angle, side. Now here's the really cool thing about these. See how DEF is in both of these congruent statements? Since both of these triangles ABC and GHI are congruent to DEF, we can skip the middleman and say that in fact triangle ABC is congruent to triangle GHI. And if you think about that, the property that says you can skip the middleman, that's your transitive property. We just proved two triangles congruent, and our final reason wasn't side, 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 angle, side, angle, or angle, side. It's kind of cool. You can use a third triangle to help you figure out whether or not you have two concurrent triangles. That was the point of this. So let's dive into talking about proving parts of triangles congruent. So, if we're going to prove parts of triangles congruent, the first thing we need to do is prove that we have congruent triangles. So we're going to start with our given. Here's your given. Angle KBC is congruent to angle ACB, and angle K is congruent to angle A. Those are already marked in the diagram for us. The next thing I would look for is a side, since you've got two angles. Here's one angle, here's the second pair of angles. You need a pair of sides, and I noticed this side that's shared. Anytime you see a shared side, that's where you should go immediately in your proof. You want to say that CB is congruent to CB. Something is congruent to itself. Now, you might want to be careful about that order. What's the one correction we can make about this? If you notice, BC corresponds to CB, so I would probably change the second one to be a BC. Which means that right here, we're not going to have the reflexive property, we're going to have the symmetric property. Now, if you look at that then, you add that congruent marker to your drawing, the top triangle has angle, angle, side, and the bottom triangle has angle, angle, side. That means that in fact, we have congruent triangles by angle, angle, side. Now the whole goal of this proof is not to prove triangles congruent, but to prove that KB and AC are congruent. And here's the really cool thing. If you can show you have congruent triangles, that means all their corresponding parts are the same. And if you notice, KB is the first two letters and AC is the first two letters. That means side KB and side AC over there are corresponding. And we have this theorem that says the corresponding parts of congruent triangles are congruent. And that's a lot to write. So the way that we abbreviate that is CPCTC. First letter of each of those big words. Corresponding parts of congruent triangles are congruent. So basically, we're doing the proofs that we've done all chapter, and then we're adding one extra step. We're proving we have congruent triangles, and once you have congruent triangles, you can in fact show that all their corresponding parts are congruent. Let's try another proof. All right, we're going to start with our given. Given that BA is congruent to DA and CA is congruent to EA. So we've got two pairs of sides, which means we need a pair of angles. And so I went and I looked at the picture and I said, hey, here's a big X. Anytime you see a big X in your mind, you just think vertical angles because we have congruent vertical angles are congruent. You notice the order, it goes CAB and EAD are in fact congruent angles by the vertical angle theorem. Now look at the order. You've got three pieces of information. Two pairs of sides and one pair of angles. If they're in side angle side order, we're good to go. So I checked that. I've got a pair of sides, a pair of angles, and a pair of sides. That is in fact side angle side order, so my triangles are congruent. Now the final goal is to prove you have congruent angles, that C and E are congruent. Well, once you get congruent triangles, their corresponding angles are congruent, because the corresponding parts of congruent triangles are congruent. CPCTC. All right, we got two more proofs to go today. Thales was a Greek philosopher, and he is said to have developed a method to measure the distance to a ship at sea. He made a compass by nailing two sticks together, and standing on top of a tower, he would hold one stick vertical, and he would tilt the other until he could see the ship along the line of the tilted stick. With this compass setting, he would find a landmark, L on the shore, along the line of the tilted stick. How far would the ship be from the base of the tower? All right, so this is what it would look like. Thales would stand up here at T on top of the tower, and he would tilt a stick to go look at the boat, so that's that side, and then he would turn it to find a landmark, because then he could measure the distance from the tower to the landmark, because he could measure across land but not across water. So what we're going to do is we're actually going to prove that what Thales is doing is correct, that that distance from the base of the tower to the landmark and from the base of the tower to the ship is the same length. So let's set up our proof. We're going to do a two-column proof on this one. So we'll set up our statements and our reasons, fill in your given. Now we're going to have to go back and forth to this picture a lot, so there'll be a lot of scrolling going on here. If you look at this picture, once you get your given filled in, we know that TRS and TRL are right angles, so here's TRL, right angle, and TRS, another right angle. We know that RTS, angle RTS, or RTS, right here, is congruent to angle RTL right there. We're going to prove that, in fact, not only are these congruent angles, but we have congruent triangles. So with all of these congruent parts that they gave us one pair of angles, and then they talked about some right angles. First thing that I see up here, though, is I see this obvious shared side, TR. TR is going to be congruent to itself. And so we can add that to our proof right off the bat. TR is congruent to TR. The order would stay the same, so that's your reflexive property. Now, that gave us a pair of angles, one pair of angles, and one pair of sides, which means we either need a second pair of sides or a second pair of angles. Now, in the given, they did tell us that we had a pair of right angles, which we marked down here in green. And you should know by now that all right angles are congruent, so that's where I would go next. Angle TRL, which is your right angle, you know that from the given, is congruent to angle TRS. It's another one of your right angles from the given, because all right angles are congruent. Now, if you look at that, you've got a pair of angles at the top. You've got a pair of sides, and that gives you a second pair of angles. That is classic angle, side, angle congruence. So in fact, we have congruent triangles by angle, side, angle. But remember, this is a corresponding parts of congruent triangles proof. This is not a congruent triangles proof. So the whole goal of this is to prove that Thales was right. He could do these measurements. The distance from the tower to the landmark is the same as the distance from the tower to the ship. And because the triangles are congruent and those are going to be corresponding parts, we can say that RS, the distance from the ship to the tower, is the same as the distance from the landmark to the tower, RL, by CPCTC. We've got one proof left to go in your notes today. So it says, given that AB is congruent to AC and M is the midpoint of BC, prove that you've got congruent triangles. So let's set up our two-column proof. Let's start by putting in our given. AB is congruent to AC. M is the midpoint of BC. All right. So the first thing I would notice, these two triangles share a side, which means that side is congruent to itself. AM is congruent to, now I want to make sure I get that order correctly, so I'm going to go look at the given statements. They tell me AB is congruent to AC, so A corresponds to itself. So the order is going to stay the same. If the order stays the same, it's your reflexive property. Now, they give you another piece of information in the given, and what it says is that M is the midpoint. We should know by the midpoint now is that it's the middle. It cuts a segment in half. So if you go find BC, here's BC and M is the midpoint. That means M cuts it into two congruent parts, which means that BM is in fact congruent to CM. Your reason for that is just the definition of a midpoint. Now, if you look at that, I've got three different side markers on there. You have side, side, side triangle congruence. We can in fact say that triangle, now I'd be careful when you name these. I'm going to go AMB. AMB is congruent to triangle. Well, we know that A corresponds to A, M corresponds to M, which means we must put C last. Now we prove we have congruent triangles so that in the end we can have congruent parts. So our final step is angle AMB is congruent to angle AMC by corresponding parts of congruent triangles are congruent. CPCTC. This was lesson 4.4 for geometry. The goal was that you would be able to use triangle congruence and corresponding parts of triangles to prove that parts of two triangles are congruent.